Good morning. Today we are doing CO23. Today we are still working with those factors, but this time we are finding the greatest common factor of a set of numbers. So now instead of just looking at one number and its factors and prime factors and all of that, now we're comparing numbers and we're finding that greatest common factor. So we need to remember what factors are. Factors are numbers that go evenly into a given value. So we can't end up with decimals, right? It's those factor pairs, factor buddies that we've been talking about. 22 can be broken down into 1 and 22, 2 and 11. Those are the factors of 22, what we can break it into those factor pairs. So an example would be 2 and 9 are factors of 18. Or 6 and 5 are factors of 30. It's finding the factor buddies. Okay. There are 3 methods we're going to go over for this. We're going to work on prime factorization, what we did with yesterday's objective. We're going to talk about listing and the table method. So I'm going to go over how to do those 3 different methods. First one is that prime factorization. So we're going to do what we did in yesterday's objective for all the numbers that we are given. And then we have to compare them. So we have our 18 and we have our 15. What factor pair should I use for 18? Zelda.
You can do either 6 and 3, or you can do 9 and 2.
Which one do you want me to use, Zelda?
3 and 6.
Okay, so like Zelda said, sometimes we have multiple factor pairs to pick from. Does it matter which one we pick? No, because we'll get the same answer no matter what, because the prime factorization will be the same. It is its special genetic code for that number. So no matter which factor pair you pick, when we break it down, it's going to be the same prime numbers. Is 3 a prime number? Yeah. So we're going to just bring that 3 down again. Is 6 a prime number? No. What can I break the 6 into? Madeline? 2 and 3. So my prime factorization is 2 times 3 times 3. So now I have to do 15. What can I break 15 into, Madeline? 3 and 5. Is 3 a prime number? Is 5 a prime number? Yeah, so I can't break it anymore. So my prime factors there are 3 and 5. So now I need to find what my greatest common factor is. So I need to look at which prime numbers they share. They only share 1, 3. So my greatest common factor is going to be a 3 because they only share 1 number. So what I do is I circle the numbers that they share in common. And then if it's just the 1 number they share in common, I know that's my greatest common factor. Now we're going to do it for 42 and 30. What factor buddy should I start off with for 42? Layla. 14 and 3. Is 3 a prime? Yeah. Is 14 a prime? No, so I have to break that down. What can I break 14 down into? Callie? 7 and 2. So I'm going to write that down. 2 times 3 times 7 are my prime factors. You have a question, Claire?
Yeah. For 42, you also do 6 and 7.
You could do 6 and 7. If we had done 6 and 7, I would break the 6 down into 2 and 3, and that 7 is a prime. So I get the same prime factors. So Layla went for a bigger factor pair. You could go to a different one that whatever comes to your mind first. Doesn't matter which one, we get the same answer. All right, for 30, what factor buddy pair should I use? Ava?
15 and 2.
15 and 2. Is 2 a prime?
Yes.
Yes. So I can't break it up, but I can break up the 15. What can I break my 15 into, Marina? 3 and 5. So I'm going to write out all of my primes because I can't break up 2, 3, or 5. Those are all primes. So now I have to look at what I have in common. They both have a 2 and they both have a 3. Uh-oh. The last time it was easy because they only shared one prime. But now they share a 2 and a 3. What do you think I need to do to find what my common factor is? Melanie?
Well, since we're trying the greatest common
Yep.
factor, so you would find the bigger number.
So I like your thought that you would just write what the bigger number is. But remember, this is prime factorization. So we've got a little bit more that we're going to do. What do you think, Kelly?
Do you think multiply?
Ding, ding, ding. Because we know that prime factorization, we're multiplying them. So we're going to do 2 times the 3, which gives us 6. So whatever factors they share in common, you have to multiply them together to get the greatest common factor. So yep, they both share 2, they both share the 3, but we want to get to the greatest one, so we have to multiply them. Liv?
For that problem that we just did,
Uh-huh.
could I have done 3? No.
3 would not be the greatest common factor. 3 would have been just a factor. Or wait, which part would you have done 3?
Like when you put 2 on the.
Would I broke up the 30? Or
Yeah.
which part?
Could you put like right here, can I would try to do 3?
So just like what Claire had asked with the last one, you could have done 3 and 10.
Oh, okay.
And then you would have brought the 3 down, and that 10 would have been 2 and 5, and we would have gotten the same primes.
Okay.
So it doesn't matter which factor pair we start with, whichever one comes to your mind first. If you look at 30 and say, oh, that's 3 and 10, yep, but you're going to break it down to the primes, just like we did with 2 and 15, and we would see that they share that 2 and the 3. Okay? So it's totally fine to do a different factor pair because we get the same prime factors. Now we have 3 numbers. Whew, what do I do with 3 numbers? Layla? Say it louder, Layla. Yeah, I have to break them down into 3 trees. What should I use for the 12? Zelda?
You should do 3 and 4.
3 and 4. We know 3 is a prime. 4 can be broken into 2 and 2. So we have 3 times 2 times 2. What should I use for the 30? Liv, what should I use for the 30? Oh, I know. What should I use for the 30? What did you just say we should use for the last 30?
3.
And?
10.
Yeah, 3 times 10. 3 we know is a prime. 10 can be broken into a 2 and a 5. So this time we have 2 times 3 times 5. What should I use for the 60? Hannah May?
20 and 3.
20 and 3. Now, if you had a different one come to mind, it's okay. Use whichever factor pair comes to mind. We will get the same prime factors at the end. 3 we know is that prime number. 20 could be 4 and 5. So we can still break down that 4 into 2 and 2. 5 is a prime. So we have 2 times 2 times 3 times 5. So now we have to go back and circle the primes that they share in common. So they all have a 2. Now this one had 2 2s and this one had 2 2s. but the 30 only had 1 2. So I can only circle 1 2 for each number because they don't all have 2 2s. So you can only circle it once. So I know that they share a 2. They all share a 3. Is there anything else that they share? I'm going to go back. 2 of them share a 2. So since 2 of them share that extra 2, we can circle that one. Because 2 of them share it. Sorry. Trying to adjust my brain for this fine Wednesday morning. So because 2 of them share the 2, we can circle that 2. So we have 2 times 3 times 2. Nope, I was right the first time. Wow. I was wrong in the manual was wrong. So I was right the first time. Oh my goodness. I am sorry if this is confusing you. My bad. So let's look at this again. You can only circle if all 3 of them have it. So you can only circle the ones that they all share. So they all share a 2, they all share a 3, so my answer is the greatest common factor is 6. The reason that this makes sense is if we look at 30, if we put that other 2 in there and said 2 times 3 times 2, that would have given us 12. And our answer is 12 is not a factor of 30. Does that make sense? Okay, so prime factorization we learned yesterday, that's how we use it. With our listing method, we have to look at 25 and 40, and we're going to list all of their factors. So list all the factor buddies. So we know for 25, we have 1 and 25. What other factor buddies do we have for 25? Madeline? 5 and 5. I'm only going to list it one time. So it has a factor of 5. Now, what about 40? What would my factor buddies be for 40? Melanie?
20 and 2.
20 and 2. Madeline? 4 and 10. Anna Mae?
40 and 1.
40 and 1. And there's another one. Hannah?
5 and 8.
5 and 8. So what gets hard with the listing method is sometimes it's easy to forget a factor buddy pairing. Okay, so we have, if we're doing the listing, we have to make sure that we list every single pairing. The way I do this to make sure I'm getting it all is I look at it and I go, okay, with 40, I know there's going to be a 1 and a 40, 2 and 20, 3, nope, 3 doesn't go into 40, 4 does, 4 and 10, 5 and 8, I know 6 doesn't go into it, 7 doesn't go into it, and now I'm already to the 8. So I go through my numbers to see if they're divisible by each of those numbers, to see if I can divide by the 2, divide by the 3, divide by the 4. So that way I don't miss any. Then we have to go and say, what is the greatest, which ones do they share in common? Well, they share the 1s, and they share a 5, but they don't share the 25. So which is the greater number, 1 or 5? Zelda?
1.
The greater number?
5.
The 5 is bigger. So my greatest common factor is 5. Again, if you're listing, you have to make sure you don't forget any. I'm going to have you listing for the 2 other sets of numbers on your own, checking to make sure that we don't miss any factor pairs. So now let's look at how we do the table method. The table method we write down our two numbers and we say, what is a factor I can pull out? I know that they share a 7. 21 divided by 7 would give me 3. 35 by 7 gives me 5. There is nothing I can pull out of the 3 and the 5 together. So the only factor that they share is that 7. If I look at the 15 and 50, I know, let's go through a few more. Because 7 is a prime, I'm looking to see if there is a prime that I can pull out. 7 was a prime, I could pull out of both of them. And then I divide them by that prime, and I look at what's left and see if I can pull any other prime out. So let's look at 15 and 50. What prime can I pull out of 15 and 50? Callie?
5.
A 5. 15 divided by 5 is 3. 50 divided by 5 is 10. Is there another prime that I could pull out of 10 and 3? No. So my greatest common factor is 5. So now I have 3 numbers. What is a prime that I can pull out of 14, 28, and 49? Can you give me those prime numbers? Madeline? 7. 14 divided by 7 is 2. 28 divided by 7 is 4. 49 divided by 7 is 7. Is there another prime I can pull out? No, so my greatest common factor here is 7. So I do want you to finish those last 2 listing methods. Okay, listing all of the factor buddies and finding the one that is the biggest one that the numbers share. But I want us to be able to have some work time today and to come and ask me questions if we have questions. So we're going to look at our second page to see what our work is for today. This one says pick a favorite method and find that GCF, the greatest common factor. Show your work. You might be able to look at some of them and go, oh, I know in my head, I can do mental math with this. But we're not doing mental math on this. We're showing which method we used and how we used it. So even if you can look at it and do the mental math, like I looked at this one and I used mental math to know what the number was, I'm going to have to show it. I'm going to do a prime factorization tree. I'm going to list all of the factor pairs, or I'm going to do the table method. Show which method you use to get your greatest common factor. It is important that we show our work. Then we have some word problems. Oof, let me get rid of that. We need to be able to answer the word problems. Just look it through. Yes, 8 sandwiches, 20 beef jerky sticks, 12 strawberries. We're going to find the greatest common factor of all 4 of those numbers. So instead of doing 2 or 3 numbers, now we have 4 numbers we need to find the greatest common factor for. Still doing the same kind of math. Finding the answers the same way, but now it's with the 4 numbers. And then just for funsies, how many of each item would be in the lunchbox? Here's a hint. Look for its factor buddy. When you find how many identical lunches will there be, what would be its factor buddy to get to that number? So if you find let's just say there's 8, which is not the answer, but if there were 8 identical lunches, how many sandwiches would be in each of those lunches? What's 8's factor buddy for 8? 1. 8 times 1 is 8. So there'd be 1 sandwich in each lunch. So that's what you would write. The answer is not 8 identical lunches. I was using that as an example. Okay. Yes.
Do they mean like 44 gusher like bags or like just like individual?
It doesn't matter. Just 44 gushers.
Okay.
And then do the review at the bottom. Okay. Any questions on today's assignment? So make sure you list all of the factor buddies for these last 2 that we didn't do. And then pick which method you want to do, if you want to do the prime factorization, if you want to do the listing, or if you want to do the table. Find the greatest common factor, show your work, and then do the word problem, finding the greatest common factor of those 4 foods. If you are at home, I hope you are well. I hope to see you soon. Have a wonderful day.